So three, as I tell you, in this chapter, we have to study about three quantities, voltage, three, Amar, Akbar, Antony. So Amar, Akbar are done. Today we'll study about Antony, and Antony is nothing but resistance. So quick recap about our formulas, which we'll keep on using. As I say, the first formula was voltage is equal to work done upon charge. Okay. Number two, we got to know about current. Current is equal to Q upon T. Remember that this is measured in ampere, this is in coulomb, this is in seconds. This is measured in joule, this is in coulomb, and this is measured volts as volt. Okay. To measure this, you need a device called ammeter connected in series, low resistance, and to measure voltage, a device named voltmeter connected in parallel, and high inbuilt resistance. इतना ही हमने सीखा है. High inbuilt resistance, ammeter has got low resistance. Today what we study, इतना कुछ जब पढ़ लिया, so by now one idea that we have got is, let's start taking a conductor, okay, a cross section of a conductor. This is a conductor, right, and this is my conductor. So one thing that we have got to know now, that what is current? Current is constituted due to the flow of charges. जब charge flow करेगा, current बहेगा. और charge कैसे flow करता है? Charge हमेशा high potential to low potential जाएगा. Okay, the charge will always flow down the potential gradient. That means that I can have a current which can flow through this conductor as long as these two terminals, that is terminal A and terminal B, have a potential difference between them, and obviously A should be at a higher potential, B should be at a lower potential, so the charge flows and current is constituted, right? Forget about the flow of electrons, opposite and all. For us, current always flows along the direction from positive to negative. So I am maintaining this with a positive potential, and this is at a negative potential. So the current will flow as long as you have a potential difference. And what is the potential difference between these two terminals? We say the potential difference is VAB. ठीक है ना? ये समझ में आ रहा है? I will rub this portion off. So you should know that if there is a potential difference, then there will always a current that will flow. Now the question arises, how does the current flow? We always know that if I make a potential diagram like this, let's say this is A and this is B, this is the potential at A, VA, this is the potential at VB. VA is at a higher potential, so obviously the gradient is in this direction, so the current flows in this direction, right? Now, if you want to increase this current is like a baby who is sliding down the ladder in a park. So if you want the baby to have a much more faster fall, what would you do? You will increase the slope. तो इस slope को बढ़ाने के लिए एक और रास्ता है कि आप VA को बढ़ा दीजिए. इस कहानी से हमें ये पता चलता है that if V is the potential difference, V now stands for PD across A and B, right? If V is the potential difference across A and B, then the current flowing through A and B is directly proportional to V. Have you understood this or not? जितना potential difference होगा उतना ज़्यादा current जाएगा. So what do we say it as? We write the statement, make this figure धीरे धीरे, make this figure, and you write that the current flowing through the cross section of a conductor, or the current flowing through a conductor, is directly proportional to the potential difference maintained across its ends. Amulya missing? How many missings today? Mulya. Okay. Current flowing through a conductor is directly proportional to the PD across its ends. Means if you maintain more PD, more current will flow. समझ में आया? We're going back to grade 8 level, right? So in direct proportionality, we can also flip this. We can also say voltage is directly proportional to current. अगर current ज़्यादा जा रहा है, it means that obviously the voltage maintained must be more. Have you understood? Now it's a directly proportional. Therefore, we say that this voltage can be now made equal to I as long as I put a constant of proportionality out here. Like grade 8, yeah. V will be equal to some constant into I, and that constant is known as R. This R is the constant of proportionality right? And this R is known as the resistance. The resistance of the conductor. The resistance of the conductor or the resistance offered by the conductor. Resistance of the conductor or the resistance offered by the conductor. And we get a very standard relation from here. V upon I is equal to R. ये लिख लीजिएगा V by I equal to R. Right. यहाँ तक anyone has not understood? Just quick recap. If you maintain more potential difference across two ends of a conductor, more current will be flowing. So the current flowing is directly proportional to the PD across A and B. That means the PD across A and B is also directly proportional to current. If current is more, obviously the PD is more. And then we want to equate the two. So we have to introduce a constant of proportionality, which is known as R. And R is known as the resistance offered by the conductor. This entire thing is known as Ohm's law. Ohm is the name of a person. और ये बहुत important law है, बहुत help करता है. It is known as Ohm's law. So you can write down state Ohm's law. State Ohm's law was what you wrote in the first. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, provided एक और word लिखिए. Now you're writing Ohm's law. लिखिए Ohm's law में लिखिए. Ohm's ये common question है. State Ohm's law and write its mathematical relation. The current flowing through a conductor, आराम से. Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, provided temperature and other physical parameters remains unchanged. When you bag रख के comfortable हो, okay, remains unchanged. Temperature and other physical parameters. Other physical parameters means geometric parameters, like you should not make it thin, thick, or bend, ये सब नहीं करना चाहिए. Physical parameters. तो ये क्या कहता है? ये जो relation है ना, V equal to IR, this is more in the language of electricity, we read this relation more as V equal to IR. RI, we correct है? This is more known to people. V equal to IR holds good only when temperature does not change. Means if you increase temperature or reduce temperature, this law will not hold. And if you change physical parameters, जैसे you know the dough of atta. So atta dough you are making like this, so it becomes like a lamba ladi. Now you can, if you pull it further, the cross section becomes thinner and thinner. The length goes on increasing. That's called a change in physical parameter. That you are not allowed to do. ये अगर वायर है, इसको खींच के पतला मत कीजिए, ना ही इसको मोटा कीजिए, जैसा ही वैसा ही रहने दीजिए, और उस एनवायरनमेंट का टेम्परेचर के साथ छेड़छाड़ मत कीजिए, तब ये लॉ आपका एप्लीकेबल होगा. नेक्स्ट लाइन लिखिए. Don't think that all conductors will obey this. Every conductor doesn't obey this. So right, conductors, ये लेना, conductors that follow Ohm's law, are called ohmic conductors. Conductors that follow Ohm's law are called ohmic conductors, and those which does not follow are called non-ohmic conductors. OHMIC. Ohmic, non-ohmic. Ohm's law states that the current flowing through a conductor is direct. This is Ohm's law. the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, provided the temperature and other physical parameters of the conductor remain unchanged. You should not do any छेड़छाड़ with temperature or with physical parameters. ठीक है, इसमें बहुत कुछ सीखना है अभी. कहाँ पे लाइट? कहाँ पे लाइट? That's wire. That's a wire going through. That's a casing. The same casing like this. Acrylic casings. And this much done? Okay. Okay. चलिए. अब आते हैं. So in your you started with your these relations ना. So write down. Add one more now. V by I equal to R. That's your third formula. Fourth formula V is equal to IR. उसी से जन्म लिया है. V by I equal to R. Fourth formula is V equal to IR. ठीक है, आओ अब देखते हैं थोड़ा सा इस फॉर्मूला को वापस. We say Ohm's law standard format is V by I equal to R, or it's V is equal to IR, right? As I write this formula, just start thinking, going back to coordinate geometry, y equal to mx plus c ऐसे सोचो. What is the value of c out here? 0. That means this graph will start from 0. No voltage, no current, right? आ जाओ बनाते हैं ओम्स लॉ का ग्राफ. कभी भी आप भूल जाओगे ना, ये आपको आएगा ही आएगा. इसके ऊपर बहुत क्वेश्चंस आते हैं. नाउ वी स्टार्ट गेटिंग इनटू कंफ्यूजन. व्हाट इज माय एक्स एक्सिस एंड व्हाट इज माय वाई एक्सिस? सो एज आई टोल्ड यू, वाई एक्सिस इज वाई. व्हाट इज वाई एक्सिस? वी इज वाई एक्सिस. वी वोल्टेज, दिस इज करंट. सो वी इक्वल टू आई आर, वाई इक्वल टू एम एक्स. दैट मीन्स it starts from 0 because our c value out here is 0. IR means IR plus 0 na, so c is equal to 0. So ohmic conductors, this is an experiment that you do in grade 12. Even in grade 10 we used to do. For ohmic conductors you'll always get a straight line. You'll always get a straight line, right? And say at this point you have measured the current to be something like say IA, and the voltage you measured here was VA. Okay, so this will be known as my rise and this will be known as my run. So what is your slope? Slope is always equal to rise upon run. So look at this equation. The slope should be what? The slope should be R. R is your slope. इसको इसलिए ऐसे लिखो because your axes are like this. RI करके लिखते हैं, ठीक है ना? So this is what is for M. X is represented by I and this. So you get VA upon IA, which is the resistance of the conductor, and this slope remains constant. Straight line. What is the other definition of slope? Slope is the given by the angle that the line makes with the positive direction of x-axis. Now if it is a straight line, this line is always going to make the same angle. So this ratio never changes. So in labs you will be actually given a small setup. How this thing is done in lab as an experiment, we can do it in lab as an experiment also. अब इसको कैसे करते हैं? I'll show you. So this is a typical characteristic. What is it called? It's called the characteristic of Ohm's law. Characteristic means the graph, VI graph. And remember which axis what comes. If you forget, remember as y equal to mx. Y is always v. R is the slope. समझ में आया बच्चा? Clear so far? Okay, now start. Let's see how to do this as an experiment. इसको experiment wise कैसे हम कर सकते हैं? So let us set up one small experiment, and that experiment would be, let's say we have a cell, okay, which is giving us a voltage V. And then what do? We have we'll have an ammeter also in the circuit, and we'll bring a resistance. Resistance symbol is like this. This is a resistance, okay. And so So this can be resistance means this is any wire. This is any wire given out here. Let's say a small piece of wire is given to you A and B. You have basically connected this wire AB out here, okay? And you want to verify it for Ohm's law. तो आपने यहाँ पे एक एमीटर ले लिया, ठीक है? Now how do you verify Ohm's law? You have to get a straight line curve. So for different voltages you should get different current, ठीक है? तो हमें क्या measure करना पड़ेगा? To measure the current we have put the ammeter. देखो देखोगे तो ही समझोगे, हाँ. To measure the current, we have put up the emitter. So now we need to also measure what is the voltage. So what we do, we connect a voltage out here, voltmeter out here, and voltmeter is always connected in parallel. So this will measure the voltage across R. Now try to think about Ohm's law. Ohm's law क्या बोलता है? Current flowing through a conductor. This is the conductor which is behaving. Every conductor has some resistance. Resistance is like some sort of a stubbornness. Please allow the current to go. नहीं दूंगा जाने के लिए. Everyone, right? So the current flowing through a conductor is directly proportional to the potential difference maintained across its ends, right? So how much potential difference am I supplying? I'm supplying V. If I'm supplying V, this meter should be maybe something like say 6 volts. So this meter should show at 6 volt. Now we have to get different iterations, right? So we make one, say we make one chart in our lab book and we say serial number. So here we will see what is the voltage we are applying. Here we'll see what is the current we are applying. And in this case, we will do V upon I. Pura same तो नहीं आएगा because you won't get all the points straight. If you get all the points straight, you should get a 0 in lab because it's not ideal. एक दो point बाहर आएगा ही आएगा. So अलग-अलग voltage लेना पड़ेगा. अब अलग-अलग voltage के लिए आप क्या करोगे? आप cell निकाल के फिर cell डालोगे, ऐसा नहीं करते हैं. So there is another device available which we call as a variable resistor. The symbol of variable resistor is something like this. बनाइए, so जरूरत पड़ेगा आपको. This is called a variable resistor. Means you can change the. Okay, this is called a variable resistor. Another symbol for variable resistor is like this. And then on this side we will put one arrow. And this arrow stands for this is the jockey. Do you understand? Jockey मतलब कैसा है? ये jockey move करेगा इसके ऊपर, slide करेगा. नहीं वो ऐसा होता है, आपको दिखाऊंगा वो इसका क्या यूज होता है. अभी आप कितने हंसोगे, देखो मजा आएगा. Do you understand what is happening here? See, let's say this point is X, this point is Y, right? And suppose you bring the jockey head J right on X. Then you are making a current flow through the circuit without the resistance at all. देखो नहीं देखोगे तो नहीं समझोगे. Say this resistor is of a value of 100 ohms. मैंने अभी तक यूनिट नहीं बताया आपको. 100 ohms. This is a resistor. 100 ohms resistor. If you want to use fully, then this jockey, हमारा current यहाँ आ रहा है ना, पूरा resistance you want. You slide the jockey till here. तो वो पूरा 100 ohms resistance को feel करके जाएगा. And suppose you don't want any resistance at all, full current should pass through the circuit. You bring it here. थोड़ा current चाहिए, बीच में रखो. आप रोज यूज करते हो ये चीज. फैन का रेगुलेटर. different steppers you are having. Why is the fan moving with different speed? The fan senses more current, more speed. Voltage कम कर देता है वो. Not current, rather voltage कम कर देता है. So now your head should think like that. Sir, instead of the fan, if I would have connected a bulb out there and used this, ये सब के लिए मुझे मार पड़ता था बचपन में. I used to do that. And then what I used to do? Dim light, medium light, more light. And my dad used to get angry on me. But कुछ सीखने को तो मिला. Some fan point was there which did not have a fan. So what I did, I connected a glass wala bulb. Regulator is there. So I used to say, look, this is like drama. Tuck, tuck, tuck. So it goes on and opens like that. Have you understood? Now this device is known as a rheostat. R-E-H-O-S-T-A-T. This you will typically see only in a lab. You can Google for the image. Rheostat, आप मारो आपको image दिख जाएगा. ऐसा बड़ा सा device होता है. Yo heavy. It's like a girl का जो bangle stand होता है ना, वैसा heavy stand है. And you're supposed to move the jockey like this. And you'll automatically see. So what we will do now, we will connect a rheostat out here or a variable resistor. So we'll have a variable resistor. Now, why did we connect this variable resistor? So that we can adjust this resistor and change this voltage. इसको हम change कर सकते हैं. We can change it, not basically this. The volt यहाँ पे V को vary कर सकते हैं अभी. We can vary the V. Go on sliding this. Are you understanding? The battery is going to give you V voltage only. पर एक ऐसा बोलता है, like the God gives you all blessings. This is the pujari. He can control how much blessing will come to you. Come, zada. So we have introduced one variable resistance. Okay. Now we start our experiment. So we start our experiment number 1, and we find that we have given a voltage V1. We give it some sort of adjustment, थोड़ा सा adjustment देते हैं, and I get a reading I1 on my emitter. What is my resistance? V1 upon I1, and I calculate the value. Keep it here. So they will tell you with this experiment, find the resistance of the unknown wire. So next time what you do? Next time two people do this experiment. After that you will just increase the voltage a bit more. So V2, you get a current I2. You will get a V2 by I2. Now if this is R, this should also be near to R. थोड़ा आगे पीछे होएगा, near to R. ऐसे कर करके the teacher will tell you to take 5 readings. After you have 5 readings, then you take the average, and then you finally conclude your experiment that so and so is the resistance of the. You'll get something like say 3.1, 3.11, 3.14, 3.09, 3.08, and then you take the average and you say this is my resistance. Have you understood how to find the resistance of a wire? To find the resistance of a wire, all you need is you need a constant voltage source. कुछ भी एक voltage source ले लीजिए and connect the wire, connect an emitter and this. Is this making sense? Now some things about resistance that we did not write. Right. The unit of resistance is ohm. The unit of resistance is ohm, and the symbol is this is the symbol omega. So you can write it as like 1 ohm. This is 1 ohm. The unit of resistance is ohm, and its symbol is omega. ठीक है, छोटा छोटा बना, इतना बड़ा क्या, इसके बहुत सारे सर्किट्स बनाएंगे. This is a variable resistor, and this is a rheostat. Though are same things, names are different based on their look. What is, then you will say, sir, where have I seen it practically? Volume button. In radios and all, you have the volume button. That is variable resistor. Or the one that you see, the dimmer. Many people have fan. The fans that we have regulated are called steppers. Tuck, tuck, tuck. There is something called a dimmer also. उसमें आवाज नहीं होगा. That is a variable resistor. So denoted as this. So now it's time for us to define 1 ohm. So let's try and define 1 ohm. So V upon I is equal to R. So we are supposed to define 1 ohm. That means this ratio should also be 1. So how do we define? We say the resistance of a conductor is said to be 1 ohm. The resistance of a conductor is said to be 1 ohm when a current of 1 ampere flows past its cross section comma, when the potential difference across its ends is 1 volt. बहुत सारा सब चेंज कर सकते हैं. When the potential difference across its ends is 1 volt. We can also write that the 1 ohm, the resistance of a conductor is said to be 1 ohm when a potential difference of 1 volt across its ends allows a current of 1 ampere to pass through it. खुद बनाओ ना, खुद बनाओ. देखो और एक लैंग्वेज से भी लिख सकते हो. You have written one language, see another language. The resistance of a conductor is said to be 1 ohm when a potential difference of 1 volt applied across its ends allows a current of 1 ampere to pass through it. अगर 1 वोल्ट मेंटेन करने पे 1 एम्पियर नाम का करंट दौड़ के जा पा रहा है, तो उस वक्त वो कितना रेजिस्टेंस ऑफर कर रहा है? 1 ओम। अगर 2 एम्पियर जा सकता था तो 2 ओम, 3 एम्पियर तो 3 ओम। समझ में आ रहा है? राइट। ओके, कैन आई रब दिस? सो फार अब तक क्या पढ़े हैं जरा देख लेते हैं फटाक से। नंबर 1, टुडे वी स्टार्टेड विथ ओम्स लॉ। Do we understand Ohm's law? Sir, the current flowing through a circuit is directly proportional to the voltage, यानी कि voltage is proportional to the current, यानी कि V is equal to some constant R into I, and R is known as resistance. और further यहाँ से हम निकालते हैं that V by I is equal to R. This is a very known thing. Okay? Then V is equal to IR. Then from here we define what is 1 ohm. 1 ohm is 1 ohm. So 1 ohm is the resistance offered by a conductor when a potential difference of 1 volt across its ends allows a current of 1 ampere to pass through it. Okay, ये सीखा. Then third, we also got to know about some symbols out here. We got to know about what is a variable resistor as well as what is a rheostat. Okay, so what is a rheostat? This is a rheostat. Right. Now, after this, we also understood how to experimentally find R of a given wire. How to experimentally find the R of a given wire. Anything that you have not understood here, you can feel free to ask. Then number 5, we also understood what is the VI characteristics. VI characteristics means in engineering and physics, characteristics means basically the VI plot. So if the VI characteristics gives you a straight line, then definitely you say V is equal to IR. This is the equation that you are able to follow, straight line. That means that conductor will be known as a ohmic conductor. Sir, ohmic conductor होते हैं क्या? सारे नहीं, ज्यादातर ही नहीं। ये बड़ा आइडियल सिनारियो है। और ये सारा रूल होते वक्त याद रखिएगा, टेम्परेचर पे हाथ मत लगाना। Temperature is constant and physical properties or parameters are also constant. Otherwise, Ohm's law does not get valid. And the ones who do not follow Ohm's law is known as non-ohmic conductors. ठीक है? अब यहाँ पे 2 और चीजें सीखेंगे. So Ohm's law tells us something about what? Resistance. Something that is negative, right? Something that I wanted conductor to have more current pass through it. नहीं जाएगा ना भाई, रोक लेता है उसको. That is resistance. So resistance, something in behavior is like disobedience. बोलता हूं जो करने के लिए नहीं करता है लड़का, सुनता ही नहीं है हमारा. So there should be some obedient child also. For a okay, now the question arises, who is a good conductor? A good conductor is one whose resistance is absolutely low. Okay, but everyone does not have low resistance, right? Silver is supposed to have the lowest resistance. फैशन ज्यादा देर चलता नहीं ना, ह्यूमिड है आफ्टर ऑल. हुडी कितना देर पहनेगा वो? मुझको देख के मुझे गर्मी हो रहा है. I would have asked him to take off otherwise. Okay, so ohmic, so yeah, where I was right. So resistance will always be there. But we want that, you know, the conductor should behave properly. So silver might be a conductor जिसका resistance कम होता है. ये हम बाद में देखेंगे. There's another property to it. Now question arises, sir, means different things will have different resistances. Yes. So all have resistances. Yes. That means, sir, you say disobedience is in everyone. Yes. So who is obedient among them? The one with the lowest disobedience. तो वो obedience का भी तो कोई measurement होना चाहिए. उस चीज को 10th में हम उतना नहीं पढ़ते हैं, but you'll read a lot about it in 11th chemistry. When you look about, like in conductors, we are very much interested in resistance. When we go to electrochemistry and we talk about an electrolyte, we don't talk about resistance. We talk about इसका उल्टा, which is known as conductance. And conductance को बाद में एक quantity से लिखते हैं K ऐसे, और K को हम लिखते हैं क्या? There's a Greek letter called kappa. ये 11 में आप सीखेंगे, अभी नहीं. Conductance. So kappa, this conductance kappa is said to be the reciprocal of resistance. If someone has low resistance, that means his obedience factor is very high. His conductance means current, voltage देते ही current दौड़ रहा है, right? Do you know what is its unit? The best part in this chapter. इसका यूनिट क्या है? ओम. ये जस्ट इसका उल्टा है ना, इसका यूनिट है मो, MHO. और have you heard about this company called Siemens? SIEMENS. ये Siemens इसी से नाम आया है. इसको जब हम इलेक्ट्रिकल कंडक्टिविटी में बात करते हैं, Siemens and Motorola जो है ये वहीं से बात आता है, MHO और Siemens. But इसको हम देखेंगे in grade 11, not now. Conductance. Now few questions. Suppose they give you a plot like this. Okay. Conductor A का plot दिया, and this is conductor. There is a plot. Both are straight lines. Conductor B का plot दिया है. Which conductor? Conductance और नहीं पढ़ते हम 10 में. Gone. Which conductor has more resistance? Which conductor has more resistance? Conductor A or conductor B? ये क्वेश्चन आता है, but you should be able to answer. A or B and why? What is the resistance? Going by coordinate geometry, resistance is means slope ना, जिसका स्लोप ज्यादा है. A का बच्चा बिठाओ, बच्चा कहाँ बैठने से जोर से गिरेगा? A. हो गए तुम गलत. It is the slope of VI curve. Look at the curve. It is IV curve. हाँ. So here ulta, this one will have more resistance. That is where you are being tricked. Be very careful. जब मैंने ये बोला था ना, see, if this curve would have been VI, if this would have been VI, the plot would be like this. B will come here, A will come here. A VI plot's slope tells me about resistance. A IV plot slope tells me about 1 by resistance. आप करके देखो ना. If what is rise out here? What is rise out here? I. What is run out here? V. Is this quantity not 1 by R? A का 1 by R ज्यादा है, तो उसका R कम हुआ ना. हाँ. So whenever such questions come in exam, first look at the plot. और आपको VI नहीं देगा, मैं बार बार बोल रहा हूं, आपको IV करके देगा. Did you understand the trick of it? Sanvi, Pihu, did you all understand what I'm trying to say? Resistance is the slope of VI plot, not IV plot. IV plot में you are not getting slope, you're getting slope, but slope is 1 upon R, not R. अगर 1 upon R ज्यादा है तो R छोटा है ना. बदली कर दिया. इतना क्लियर हुआ? वेरी गुड. अब थोड़े से प्रैक्टिकल लेवल की बातें. ये जो वेरिएबल रेजिस्टर आप देख रहे हैं, these variable resistors are available for high voltage also. When we go for electrical engineering labs and all, very very dangerous item. पूरा naked रहता है वो, मतलब you have to be very careful. In electrical engineering lab, the first thing they'll tell you, no student is in contact with any student. मतलब आपको लगा तो दूसरे का, and you cannot have isolation, and you have to be very particular, shoes and all required. So these resistors are there. So in our days, अभी तुम लोगों को तो dramatics वगैरह में कोई interest नहीं है, so we used to have a lot of dramatics thing in college. So in dramas and one act plays, we used to use this a lot. Stage lighting control करने के लिए. तब कौन सा microcontroller होता है? So there is a scene where they will try to change the stage act and say ये बहुत पुरानी बात है. So stage becomes dim. So the entire plot, do you know? That's what I say ना, you all have not enjoyed. Stage, audience, between them there will be a block. In modern days, camera persons are there. So this is the control block where the audio guys sit and the control guys sit. So if we are sitting on audio, we have the entire script of the play and we know it, stage rehearsal. Okay, this is the time when we have to dim the stage. It's absolutely dark. You just get the stage light. इसमें कितने लोग शॉक खा जाते हैं ऐसे करके, जैसे जैसे बातें चल रहा है ना, you have to dim the stage light. So you're dimming it what? Using a resistor. पहले जमाने में ऐसे ही होता था. And there will be focus lamps on both sides. Lamps will have different discs, and disc will have paper. So suddenly that red paper will come and the stage will become beautiful to watch. With light, so many things you can create. तो ये भी एक काम हाथ से करोगे तो आप सीखोगे. ठीक है, चलिए अब आते हैं कि सर ये सब तो समझ लिया, रियल लाइफ में रेजिस्टर होता क्या है? एनी अप्लायंस इज अ रेजिस्टर. Any appliance is a resistor. Sir, ऐसा कैसे? Any appliance. Now let's see. Let's look at our diagram. So what is our diagram? Our diagram is we have a torch which has got two cells in it. These are the two cells of my torch. Understood, bachcha? And then the torch has got a switch. So this is my switch of the torch, and it is connected to a bulb. The torch is connected to a bulb. There's a bulb, and it's in this manner, right? These are called circuit diagrams. We'll come to them. These are called circuit diagrams. Now, this is my positive terminal, negative terminal. As soon as I tap it on, so there is a contact between these two, and my bulb illuminates up. Yes or no? Yeah. Let's try to understand how the bulb illuminates up. So the current is trying to flow through it, and the bulb. अभी आपको थोड़ा सा एडिसन के बारे में जानना होगा. देखो, ये जो चीज है ना, इसको बल्ब का फिलामेंट बोलते हैं. This is known as the filament of the bulb. This is what is the gift of Edison to world. He took so many years to find the exact material for this filament, and this is made up of something which is known as tungsten. Tungsten. And this tungsten burns up. It's for so much of resistance. This tungsten does not allow the current to flow through it. So current wants to go. Electrons are having a lot of collisions, and due to this collision, it starts generating heat. ये जल उठता है, but it does not burn out. Look at the beauty. Have you seen a bulb? उसमें पतला सा वायर रहता है. You are passing so much of voltage through it, and it starts to glow up. And when it glows up, it should catch fire. So to prevent that fire, you actually have nitrogen gas which is inerted inside. जब bulb फटता है ना, टप करके sound होता है. Whenever a bulb falls, that is nitrogen gas which is made inert. Or argon, if you put that, argon actually makes this environment inert. This is the history and story of electric bulb, which we call as incandescent bulb. Nowadays we don't use it, we use more of LED bulbs. और ये गर्म हो जाएगा. You just can't. That's why our table lamps during study days used to have this. If you fall sleepy, our dad used to tell us, just touch the table lamp. गर्मी लगेगा ना, automatic नींद चला जाता था. ये गर्म होता है ना, बहुत गर्म होता है. You just can't change the bulb. And in summers, if you have got bulbs on, then it will heat you up like anything. Tube lights, even in my childhood, I think the class 6, 7, 8, we have only studied under lamps. Lamps means all yellow colored, 100 watts. Just imagine, this is one of them is 40 watts only. Each bulb used to be 100 watt, 60 watt. गर्म हो जाता है घर. अभी भी अगर आप hatcheries जाओगे ना, जहाँ मुर्गी के बच्चे रहते हैं, hatcheries में ये bulbs रहता है, to keep the chicks warm. Incubation, yeah. ठीक है? So this is, now the question arises, why does the bulb glow? So the bulb is actually my resistance in the circuit. Have you understood? It is offering resistance, so ये जल उठता है. ठीक है? बल्ब की जगह में आपने फैन लगाया, जो भी लगाया, ये भी एक रेजिस्टेंस है. अब एक चीज सोचो. Now some common interesting things. This is your घर का plug point. In this plug point, this is known as earth, this is known as live, and this is known as neutral. यहाँ पे कितना वोल्टेज आ रहा है? This is only how much? This is 3 volts. कुछ नहीं होगा. Here the voltage is 240 volts, enough to fry and kill you. Okay. They say live. So they say that these two terminals should never touch each other. These two terminals should never touch each other. तो ये जब भी टच करा देते हो ना आप, इसी को शॉर्ट सर्किट बोलते हैं. शॉर्ट हो गया, spark arises. They say short circuit means high current will flow through the circuit, so our MCB immediately trips. Our MCB has got a current rating. So at your everyone's house, we have got a MCB. Suppose this MCB is 9 ampere. Any current more than 9 ampere flows through it, it will trip. So we've got 9 ampere, we've got 10 amperes, we have got 20 amperes, like all the AC lines are on 20 amperes. More than 20, the MCB will trip. Okay. Now question arises, if I touch these two, why does they say that there is a short circuit and why does fire come up? ऐसा कि में फायर आ जाता है, तो उसको भी सीखते हैं। देखो जनरली क्या होता है that whenever you have an appliance in AC circuit, this appliance is fed by two wires. One wire comes from live and one goes from neutral. The current actually goes through the live, और जब अगर ये बल्ब ग्लो कर रहा है ना, देन आप आराम से इसको एक हाथ से छू सकते हो नेकेड, कुछ नहीं होगा. व्हाई? द बल्ब इज द रेजिस्टेंस. द बल्ब इज द रेजिस्टेंस. इट इज स्टॉपिंग द करंट टू कम बैक, बट द लूप इज रिक्वायर्ड. ठीक है, तो अभी हम इस इक्वेशन को देखते हैं. V upon I is equal to R. Did you understand? That means V upon R should be equal to I. Do you get it? Now one shaitan bachcha, what he did, he removed this R से शौर्या. ठीक है, और इसमें 220 वोल्ट्स आ रहा है और 240, और शौर्या ये दोनों को टच करा देता है, जो कि नहीं करना चाहिए, ये शॉर्ट सर्किट है. तो R को आप जीरो कर दीजिए. एनीथिंग डिवाइडेड बाय जीरो मींस दिस साइड शुड बिकम infinite. Current starts to flow through it. Current has increased, and this will further create what? Fire. That one relation we will study. Heat developed is equal to I square RT. Heat developed I square. Square of the current से heat जाता है. एक तो current infinite हो गया है. The more the time the current goes, more heat will be generated, and slowly आपको fire आना शुरू हो जाएगा. So all these flats, you'll see all the buildings which are renovated, they will be only renovated by their style. People spend the least for electrical. You go and do a random survey here, and you ask, tell somebody, Acha, you bought a new flat, you did your interiors? Yes, yes, I did my interiors. Why didn't you put this protection switch? How much does it cost? 3000. यार बहुत महंगा हो गया यार, 10 lakhs के ऊपर बजट चला गया. People don't have any money when it comes to electrical safety. Electricity का एक डर फैलाया जाता है. Electricity is good as long as you are good with it. Safety systems are the first thing that we should do. You know what happens? Our flats typically in this apartment are so beautifully wired when they are given by the builder. When they hand over the flats, the wiring are superb. In fact, in old platinum titanium, if you open, you used to have a diagram also which will tell you which is running where. The entire job goes for a toss when you give it to the interior. The interior carpenter guy will come and he will, आप देखोगे सब wire निकालेगा पहले, and then we use different color codes. He will forget what is. Now how do you know this particular fan? If I open it from here, how do I get to know which is the wire here? There will be a bead out here. You should see the bead. If the bead is 24, look at the 24 number bead out here. That wire is this wire. So our electricians will do what? They will buy one bundle, one color. Red ही लेके आएगा. So I once got the keys of the flat right above me, and that fellow was in Delhi. He said, "थोड़ा देख लेना ना, some fault is there." Blank house. I do so much of electricals. Half an hour I just sat with my hand. When I opened the switchboard, everything is red. Generally we have red, green, and yellow. Nothing. All are red. So you'll say, "Sir, how did the electrician do?" You know what they do? They buy 10 rupees 3 colored tapes. So they'll take a red wire, and on the head they will put a yellow sticker, then a little bit of green sticker, little bit of blue sticker. That's their way to identify, and they will wire it and they'll cut that portion and go away. Now next day when you come, you start solving that Pandora's box, which is red. I don't know. So यहाँ difference है. As an engineer, how you'll, as I said, when we do that inverter job, we didn't invite anyone, alone. एक दिन ज़्यादा लगेगा, काम अपना सुकून से हो. We'll do it as per. ठीक है? So understood about resistances. Now comes the better part. So what all did we study so far? 3 formulas हो गए आपको. V is equal to W upon Q. Number 2, I is equal to Q upon T. And number 3, you have something called V by I is equal to R. And from here is equal to V is equal to IR. You know the triangle to make it, we'll show you. Okay. And you can also say I is equal to V upon R. These are the 3 datas that we have got. So on this, there can be a lot of other numericals also. Now comes the story all about resistances. अभी हमें resistance थोड़ा पढ़ना पड़ेगा. Resistance. So resistance is defined by this ohm, and its unit is, symbol is R. ठीक है? And is denoted in this manner. This is a resistor R. What can this be? Sir, this can be any appliance. This can itself be also a resistor. In market, you get resistors also. Resistor खरीदने को भी मिलता है. It can be a resistor also. We'll show you. लाएंगे सब लाके दिखाएंगे how a resistor looks like, and it can be any appliance. Now, question arises: can we control the resistance? You remember when we defined resistance, we said one thing: temperature and physical parameters remain the same. Now, question arises: is resistance material specific? Let's say I have a wire, and this wire I can make out of iron, I can make this wire out of aluminum, I can make this wire out of tin, I can make this wire out of copper, I can make it out of platinum. The question arises, sir, अगर मैं सब्सटेंस चेंज कर दूं तो क्या रेजिस्टेंस चेंज हो जाएगा? समझ में आ रहा है ना? मटेरियल ऑफ कंस्ट्रक्शन चेंज कर दूं तो क्या रेजिस्टेंस चेंज हो जाएगा? The answer is yes. For this, again, let us understand one story. ठीक है, एक स्टोरी समझते हैं. स्टोरी कैसा है? अच्छा. Right. The DNA of your body has all your codes. Whether you will become fair, dark, stout, thick, fat, weight वाला, ये सब DNA में कोडेड है. किस एज में तुम कितना मोटा हो जाओगे? समझ में आ रहा है ना? So what we have done, we are trying to clone a person. एक पर्सन का क्लोन बना रहे हैं. ठीक है. सो मान लो हमने एक सेल ले लिया है, वन सेल हैज वन न्यूक्लियस एंड वन स्ट्रैंड ऑफ डीएनए. इसको हमने सोर्स किया है कहां से? फैट से सोर्स किया है. फैट. ठीक है. फैट नहीं, इसको ऐसा ले लो, सपोज इसमें स्टबर्न से सोर्स किया है. स्टबर्न, देयर इज अ वेरी स्टबर्न गर्ल और अ बॉय, और उसकी बॉडी से एक सेल को एक्सट्रैक्ट कर दिया है. सो दिस इज वन सेल एंड नाउ वी विल कल्चर दिस सेल. इस सेल को कल्चर करते 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 एक यहां से एक छोटा सा, मान लो एक बॉय और एक गर्ल आया. ठीक है, एक गर्ल आया. और इसी तरह एक और सेल को लिया, ये थोड़ा सा ओबीडियंट से लाया हमने. ठीक है ना, ये ओबीडियंट से लाया. इसको कल्चर करते करते ऐसा एक मान लो ओबीडियंट बच्चा थोड़ा सा पैदा. Now tell me, we are now seeing them at age of 2 years or 3 years. Don't you think that the portion of stubbornness in this child will be more? It may not be, what to say, what's the word? It may not be seen in this child at this age. But ये आया कहां से? ये तो stubborn cell से बनाया है इसको, और इसको बनाया है obedient से. 16 years later. ठीक है ना? If you don't give me IPL ticket, I will not eat food. I want iPhone. बेटा थोड़े से सिंक में बर्तन है, कर दोगे? हाँ ठीक है, मैं ये प्रॉब्लम कर लेता हूँ, उसके बाद कर दूंगा. समझ में आ रहा है? अब यही बच्चा, ये अगर इसको लेके, if you put this child into environment of more where you can, अच्छा you want Android phone, I'll give you iPhone. Huh? So if you create more environment which are not good for her, the stubbornness will get excited more. Yes or no? And if you bring environment which is good for her, now if you bring stubbornness environment for her, still there will be some प्रकोप, but not like this, क्योंकि ये पैदाइशी उस चीज से हुआ है जो stubborn है. समझ में आ रहा है? अब ये स्टोरी को, ये सब stubborn और ये सब हटा दीजिए, और मान लीजिए there is the property, I will not say resistance, the property of resistance, इसमें it is something like R, it is something like plus plus R. इससे जब आगे चल के वायर्स बनेंगे, एक रेजिस्टेंस होगा. इससे जब बनेंगे, पैदाइशी थोड़ा ज्यादा है. ये समझ में आ रहा है? सो ये चीज को कौन कंट्रोल करता है? ठीक है, देयर इज समथिंग. सी आई टोल्ड यू, रेजिस्टेंस में वी डोंट टच द फिजिकल पैरामीटर लाइक लेंथ, एरिया, क्रॉस सेक्शन. यू कैनॉट टच. सो द क्वेश्चन इज, सर I have silver with me, and I have a silver wire which is 30 centimeters long and say having 5 centimeter dia. I have another silver wire which is having say 60 centimeters in length and 5 centimeter in dia. Sir, will both of them offer the same resistance? No, they will not offer. But they are coming from the same parent silver. So that property embedded in them is same, they have been brought up into different environments. As a result, this child grew up to be 60 centimeters long, this child grew up to be 30 centimeters long. So question arises that, sir, if resistance cannot be defined, what controls the property of this resistance? There is another parameter which we call resistivity. Resistivity is specific to a material. It has a unique value. Resistivity. ये resistivity क्या है? That stubbornness जो DNA में कोडेड है. सिल्वर के DNA में एक resistivity कोडेड है. ये कभी चेंज नहीं होगा. सर मैंने ना उससे इतने पतले वायर बनाए कि मतलब सेक्विन का काम कर सकते हैं कपड़ों में. You know sequins in which you do garment में जो काम करते हैं. So we is that patla wire. Is the resistivity changed out there? No. Resistivity never changes because it's the DNA. Then sir, मैंने silver लाके I made this big wires, this thick wire. Is the resistivity different? No. But the resistances are different in both cases. I hope you are able to appreciate what I'm trying to say. If you take silver, then let's take silver also out here. Ag. Ag has a unique value of resistivity. This is fixed. Now with this Ag, you want to make a strand or you want to make a cable. The resistivity in both the cases is same. What changes is the resistance. Here the resistance will not be equal to the resistance here. Resistance alag alag hoga. Resistivity remains the same. Do you understand? आगे चलें अभी. That means in resistivity, I should not use words like physical properties does not change. Change करो, मोटा बनाओ, पतला बनाओ. Resistivity does not change. So how do we define resistance as resistivity as? Resistivity को थोड़ा टेरा वे में define करते हैं, ठीक है? We say that the resistance of a conductor is directly proportional to the length of the conductor. That means more long wires you take, more will be the resistance. If you glow a bulb with this much of wire and you take a wire which is from here to Kali Mandir and going back and coming out here, the bulb will not glow that bright because you have increased the resistance. That's why after you don't expect that. Do you know HDMI cables? The HDMI cables which carry your pictures, they are digital cables. So if you don't think that you can have a HDMI cable which you link here and you will see the picture in Pearl Tower, nahi, wo बीच में चला जाएगा. So if you increase the length, the resistance increases. Further we say resistance is inversely proportional to area. The more mota you make it, the resistance falls down. The more mota you make it, the resistance falls down. कुछ click हो रहा है? Have you seen microwave का plug, washing machine का plug? मोटा. क्योंकि they need more current. More mota, less resistance, more current flows. Do you understand? Every heating device, आप geyser ले लो, AC ले लो. So next time onwards, when you see a mota plug वाला device, be doubly careful. That device is like a bullet. बहुत current पीता है वो. तो अगर मारेगा तो वो जबरदस्त मारेगा आपको. ठीक है? You don't see. So resistance is directly proportional to length, inversely proportional to area. This area is beta, the cross-sectional area. You know what is a cross-sectional area. So now let's combine these two. We write resistance is directly proportional to L upon A. Combine कर दिया दोनों को, लिख सकते हैं. तो यहाँ तो हमारा मैथ्स खत्म नहीं होता है. We need R is equal to some constant of proportionality तो डालना होगा ना. Yes or no? And that constant of proportionality is rho, density वाला rho. और ये rho कौन है? और नहीं कोई और नहीं, यही है resistivity. समझ में आया? अब देखो इसकी ब्यूटी क्या है. Sir, I want to make a headphone wire out of silver. What will be the resistance? It will depend upon how long headphone wires you want. Sir, I want that the headphone wire should be 1.5 meters so that the user can put the device in his or her pocket and at that time do Zumba also. headphone wire should be 1 meter, 1.5 meter. Okay, for 1.5 meter, we need the resistance to be blah blah. That fixed, the value will be fixed. You know the value of resistance? Yes. Do you know the value of the length? Yes, sir, 1.5 meter. What material do you want to use? Sir, silver. So you know the row for silver, it will be there. If you Google it out, it will be the row. So you are locked upon the area. Now you don't have any choice. If they say that the wire will be this much thin, then utna hi thin aapko karna padega. But sir, in that case, if the user just goes up, phat sakta, patega, then change the material. Cost. That's why different headphones have different. Sennheiser headphone and Secunderabad headphones have different prices, right? One is in thousands, one is in कितना भाई 80 का दे दे क्या 100 का लास्ट दे दो दे दिला देते तुम्हारे को वो वाला मिल जाएगा. So can we see the unit of resistivity? Let's see the unit of resistivity. अगर resistivity का units देखें तो कैसा हो जाएगा? ओम ऊपर में है, मीटर स्क्वायर will come this side, है ना, और एक मीटर नीचे आ जाएगा, तो फिर मीटर ने मीटर स्क्वायर को काट दिया. Resistivity unit is ओम मीटर. ओम मीटर. Now, how to define resistivity? How to define resistivity? Now, just look at it. If you make this ratio as 1, if you make this ratio as 1, then resistivity and resistance are same. So, how do we define? We say the resistivity of a conductor. अरे लिखना मत बड़े सुनो भाई. The resistivity of a conductor is the resistance of a conductor of unit length and unit cross-sectional area. That means, try to understand, take a 1 meter long silver wire, rather I should say a silver drum, whose cross-sectional area is also 1 meter square. That drum, the value of resistance that it will offer is the resistivity of silver, and it is material specific fixed. Resistivity has nothing to do with geometry. Geometry के साथ कोई लेना देना नहीं है. Resistance has geometry. With the same resistivity, you can create different resistances just by varying length and area. So my question to you is, I have got 5 different items with different resistivities. Okay, different resistivities. Suppose you want to make a very good conductor. Whom will you select? I would select somebody who has the least resistivity. I want to make an obedient child. So the DNA that I will bring, all of them are disobedient. I will bring the DNA from that child whose DNA is having the least disobedience. आगे चल के वो बच्चा भी disobedient बनेगा, पर दूसरे से तो कम बनेगा भाई. Sir, I want to design a resistance. I want pakka resistance. It should block current. I want to block current. Then I will take a wire of a material whose resistivity is more. मेरे को सर आगे चल के ना पक्का जिद्दी बच्चा बनाना है. Can you give me a gene or a DNA? Okay, let's see. You want a stubborn baby? Okay, take the stubborn DNA. अब ये आगे चल के और stubborn बनेगा. Understood? So these DNAs have fixed stubbornness. These materials have fixed resistivities. Based on your choice, your work need, and above all, the market has to afford your product. So we say techno-commercial viability. Silver का headphone कितने लोग खरीद पाएंगे? नहीं खरीद पाएंगे ना. So our product, suppose you make a table lamp and you say, sir, the cost is 2 lakh, sir. 2 lakh? What is it? Sir, it actually has got a bearing load of 5 Newton, and the vector analysis shows that if it falls, the mosquito will not get hurt, and for next 47,000 years, no corrosion will happen, and no wind can blow it. Bhai sahab, we don't want that. We want a product which should be, the whole engineering course is like that. In first year, you learn about raw materials. Second year, I say that you learn about processing of raw materials. Third year, you design a product which is engineeringly okay. Means the table lamp can be 2 lakhs. Fourth year, we study management and we design a product which is techno-commercially okay. these boys and girls have to buy that table lamp. So अगर आप इसे 2 लाख में प्राइस करेंगे तो कोई नहीं खरीदेगा, है ना? समझ में आ रहा है तो? But in electrical devices, our first thing is you cannot compromise safety. That's why don't buy era gera things available on the road. Star लगाया हुआ है, super light दे रहा है. There are many people who will buy a new car, hundreds. The Thar 5-door car has just got released. Just released 4 or 5 days हुआ है. Lots of reviews are there. Delhi करोल बाग में उसका पूरा एक्सेसरी का सेट आ चुका है. And the people buy and then go, आज हम आए हैं भाई की दुकान में, and then they will strip open, इसमें LED लगा देंगे, focus लगा देंगे, ये लगा देंगे. Why did Mahindra not give all these things? There is some rating नाम का भी तो चीज है ना. Just because your horse can run, you can't pull sacks and sacks on its back. But people are like that, भाई गजब भाई, भाई beast लग रही है गाड़ी हमारी, heavy लग रही है. Delhi side is all like that, beast लग रही है, Mahindra beast लग रही है हमारी. बस so many focus lamps should be there. And then let's say, sir भाई ना धुआं आ रहा था बड़ा यहाँ से, गर्म हो गया गाड़ी. Understood? So we stop our discussion till resistivity. So adding one more formula. The fourth formula is resistance R is also equal to rho L upon A. We'll do a lot of numericals on these two before going further. This is known as resistivity. कुछ लिखना था तो लिख लीजिए, नहीं तो अगले क्लास में लिखाएंगे. We'll start from resistivity again from next class, where we'll start with the definition of resistivity. ठीक है? So now you're designing your products, you're designing your wires. चलो बहुत दिमाग खा लिया तुम्हारा. Then you'll say